All right, hello everybody. Jesus Christ, that is gigantic. Is that not working? Okay, cool. Right? All right, there it is. It's fixed. Hello everybody. Okay, my microphone is working, my camera is working, my dog is a pillow. Um my stream is half working, I would say. It streaming from two different computers to two different streams has just been a mess. I don't know how else to put it. Um, it messed up my entire configuration on both computers somehow. But I seem to have done it correctly. I'm streaming to the correct channel. I'm streaming to the correct stream. I'm not streaming to my gaming channel. No. I am streaming to my programming channel. Yes. And I only have one Twitch. Which I was actually considering, like, yeah, I'm glad I only kept one. I was considering if I should have multiple ones for different types of streams, but luckily I didn't. Okay, and the names are correct, and the categories are correct on both. Surprisingly, yes. Okay, okay, everything's working. Everything's working. My camera is working. My microphone is also working. And my chat was a little bit too big there for a bit, but yeah, it's fixed. All right. Marquee tag working, the most important thing. I was supposed to update it to show a different thing every time instead of the same text all the time, but I couldn't be bothered. So, yeah, that's something for me to do for tomorrow. And I'm just gonna write it down because otherwise I'm gonna forget. Where's my phone stand? Here. Not that I need my phone for anything, but I usually like to keep it on a phone stand. Okay. No. YouTube has also made a change, and everyone's username is now like their full username, which I wonder what mine is. It shows developed from scratch. Okay. Why does it show a username for everyone else and then my name just for me? Oh, is it the same on the YouTube stream manager? Oh yeah, because I get a little yellow thing saying that I'm the guy who's creating the stream. Right, that makes sense. Okay. Well, I'm not gonna question YouTube. At this point, they're just doing whatever the fuck they want. It's their platform. Hope the eye roll was perceptible enough. Okay, so my last development stream was on Monday. There was a little bit of a Minecraft stream in between, but that's unrelated. I also changed my Twitch name. And I realized after the fact, I changed my Twitch name and streamed something completely different for the first time on the same day. So that was probably confusing to a lot of people. I actually lost followers over that. So yeah, that was definitely confusing. A lot of people were just like, who the fuck is this? Unfollow. Why is he playing Minecraft? What the fuck? I'm out of here. So in hindsight, I probably should have separated those two things a little bit. Now this computer just loves dropping frames too. For whatever fucking reason. And the funniest thing is like the other one's internet goes through here. because it's connected to this computer via Ethernet. So like, how the fuck is this one struggling with the internet connection, but the other one isn't? I don't even know. I don't know what's happening. Although it seems mostly fine. But yeah, it dropped 300 frames there, which really adds up to like 10 seconds, but still. Okay. If it's my internet. Now, if I'm on this computer, it's the damn stream itself. That's what it is. If I'm on the other computer, it's probably your internet. Because somehow, even though they both go through this same computer, the other one's internet is more reliable than this one. Like, that one's just doing more work. There's one extra node in the network. And yet this one is less reliable. Somehow. Yeah, no idea what the fuck is happening. But, yeah, no idea. Okay. Well, I don't remember exactly where I left off on Monday, but is one using LAN instead of Wi-Fi? Yeah. Connected to this computer. Like, this one is getting the Wi-Fi and then sharing through Ethernet to the other computer. And the other one is more reliable than this one. It makes no sense. Unless, I mean, the other one, like I played on Wednesday, maybe like, I don't know, there's a ton of people around for the weekend and it's just slowing down the entire network because my ISP is shit. Possible. That's a possibility, I guess. Otherwise, I don't know. What else it could possibly be. Or it just so happens that on Friday they just have bad service. Yeah, it dropped a few more frames, like 3 of them. So, yeah, there's that. Okay, yeah. Where exactly did I leave off? I don't remember, but... Okay, yes, I do. Okay, so I was working on virtual memory. I have been working on it off stream as well. So my god, it's dropping again. I swear to god, I hate streaming. I mean, I love streaming. I hate the technical aspects of streaming. I like doing it. I hate dealing with it. It also just feels like all the software involved is just shit. Like, there's not a single aspect of it that I'm just like, yeah, this works well. This is pretty well done. And considering there's some like streamers that are like nearing celebrity status, I have no idea how this hasn't gotten better. Shit, maybe it has gotten better and it was just a nightmare like a year ago. I don't know. I just started streaming in August, but yeah, still. Okay, so I was dealing with some virtual memory issues because I introduced virtual memory into my system, and there was this issue last time in which after some time the mouse just stopped working, and that was just an XHCI bug, so it was just a very simple fix. I just had to change one line. I think the emote just broke as well. Like, yeah, see what I mean when I say streaming software is shit? Capture the Mac Mini display on your other machine and stream it from there. Might genuinely do that. But you know the funniest thing is I would be working on this computer, sending the data to that computer, then sending, like processing it in OBS, sending it through the network back to this computer, and then it gets sent over to Twitch and YouTube. And yet, there's just a chance like maybe this one is struggling to keep up hardware-wise when it's both doing stuff and streaming, like encoding all the video stuff that it's encoding and audio stuff that it's encoding. That's a possibility, but I doubt it. it didn't happen before too, which is weird. And like last week, my internet was having issues, so it's just really weird. Okay. Will you let me talk without dropping frames, please? Okay, so yeah, I ran into that issue at the end of the last stream, but it was just a simple fix. Then I ran into a couple more issues relating to the terminal, but those are fixed as well. So I believe, I may be wrong, but I believe that most of the issues that I was facing are fixed. I sure hope so. Let me see, I can run a picture of my dog and a terminal, and in the terminal I can read the console. Indeed, I can. Amazing. Okay, there were some issues with reading the console because of working with files. The file system also needed to be mapped to high VA and stuff. The protagonist of the picture just came in. So I can't really say that everything is fully working. I have to check a little bit more, but virtual memory is largely working. And actually, I'm mostly ready to move all this work back to the main branch. Okay, I was a little worried about this here, saying that I need to pull 8 changes, but I did it just on the other computer apparently. And then I merged them into here. So here I have the latest changes. Okay, cool. Another thing I did is I added a cute little command line tool that I call the Wheel of Depth. Because I have a lot of to-dos in my project. And so this one just picks a to-do at random to work on. So for example, it's telling me that I should implement a simple IO. Okay, so I was looking into a way that I could put like the file that it took it from, but I couldn't find one. So tiny issue. This specific to-do is found all over the place. That's actually only 5 places, but still. But yeah. Are you serious? The same one. All right, there we go. See, so I can occasionally, when I'm bored, when I don't know what to do, pick a random to-do and fix it. If it's possible to fix it, because maybe it's something that's not needed or that I cannot work on just yet. But you know, gives me an opportunity to look at stuff. And that's always fun. Setting up virtual memory and page tables was the hardest part of my OS. Yeah, I get it. It's probably been the task that I worked on the longest. Although it took quite a break in between. Like when I moved the kernel off to the high level, and then when I did virtual addressing, I did that in different times. But can I see when I created a certain branch? Look at all these commits. All of them are from the MMU branch. No, they're not. It just doesn't show that. Okay, unless initial commit hello world for 32-bit is part of the MMU branch. I don't think it is. My debugger is not a good sign. Anything wrong was hard to figure out. Well, there is one big downside of this, and it's that GDB is more useless than it used to be because my kernel is no longer where it thinks it is. So GDB is just done working now. There's some MMU stuff here. Preparing for multi-table. Okay, this would be the first commit, October 8th. So about a month and a half. Although there were 2 or so weeks that I took in between implementing the two different things. Let's see, because there's stuff from like 7th of October, 1st of October, 30th, 27th. Oh, but there's stuff here that's unrelated. Yeah, because this is showing me also the merges from main. This is a merge. This is a merge. So yeah, it's not super reliable. But yeah, about a month and a half with a 2-3 week break in between. But it seems to be mostly working now. That's pretty exciting. That's pretty cool. That's amazing. Love that for me. Which means that I can start thinking a little bit about how to, where is it? Okay, I wanted to provide a standardized system for processes, which is one thing that I wanted to do. Essentially just kind of not necessarily standardize, but yeah, standardize a little bit of the way that the process is mapped in virtual memory, now that I can do that. Just drop the joke. Stupid allocator in Rust that supports leaks and multiple references and use after free without single unsafe or untestable feature. Rust cult, even with working code, did not believe in it. They are not ready for the C gods. It's so funny how the Rust community has made me hate something so reasonable. Because Rust has genuinely good ideas. And for that matter, I like Swift, which is like 90% of the same safety features that Rust has. And yet, I like Swift and I despise Rust. It's just a vector and each pointer is just index. Wait, is that code? Do you have the code for that? I want to look at it. Though I barely understand Rust, but I would love to look at that. Man, it's amazing how they've done that. Do relocation tables exist for OSDev stuff? What do you mean for OSDev stuff? Since technically I control processes, then yeah. Like for dynamic linking also, yeah. But you have to do everything yourself, pretty much. Which is kind of something I wanted to do. Okay. Forbid unsafe code. Okay, so it's a lot of code. Okay, main function. Use after free possible. Okay, because you're freeing it here. And yet you're, well, load. I wonder, are you by any chance Italian? Completely random question. But is it technically a use after free if you're just reassigning the? No, wait, you are Portuguese. Yeah, no, that's why I asked, because of the okay with an E. I don't know about Portuguese, but Italian spell it like that. The Alpha and PE format has relocation tables that tell you where things are, which helps debuggers map symbols correctly. Yeah, but oh, I'm not sure. Oh, I sound Portuguese. Interesting. You can call alloc after free and it will see that value multiple will be rewritten by new allocation. Yeah, but you're rewriting it. I turned the stream 2 seconds and I see Rust. We're making fun of it, okay? Don't worry. Well, you kind of have to go out of your way to use after free, but still. Not bad, not bad. If it pisses off the Rust community, I'm good. I'm happy with it. Why do I never bring a hair tie? Safe allocator that violates all Rust features. That's yeah, that's the gist of it. All right. Give it to Cloudflare. Cloudflare. What is it? Is it Cloudflare or Cloudflare? Flare. Cloudflare. I'll give it to these guys. They'll love it. Not sure what I'm up to today yet, actually. Just started. Although, okay, I don't know what I'm up to today, but I know what I'm gonna be up to on Sunday, so I'm gonna say it now. In October, I worked on a game engine, and on a game powered by a game engine. Except the game engine's code. Why was I going to redactedOS.com? I'm supposed to go to GitHub. Yeah, so the engine code is literally just this. This is the entire game engine that powers it. Because all the stuff that actually powers the game engine is located inside of the project, the game itself. Well, I want to keep working on the game engine. So on Sunday, maybe all Sundays, could be a possibility. I want to work on a, fixing up the game engine, adding new capabilities to it. Thinking of making a real project over it. We'll make C from Rust. Please do it. Please do it. And send me the link when you do it, because you have to do that. You have to make unsafe safe Rust. Okay, yeah, so on Sunday, I'm planning on expanding the game engine a little bit. I've mentioned that I wanted to make a game about hacking, and I've mentioned that I don't know what mechanics it is going to have. So most likely tomorrow night, after my usual stream, I'm going to do another stream just for gaming to actually check out some hacking games, AI.h, yeah. GameAI.h. I'll change it to GameAI. Or Brain.h. I may call it Brain instead of AI, just to get rid of that word. You know what? Screw it. Yeah, I'm renaming AI to Brain, not Brain to AI, the other way around. Okay, yeah, so I am considering still what mechanics I want to put in a hacking game, but tomorrow I'm going to play some games for research. Tomorrow night after my usual stream. So in the afternoon, I'm going to do operating system stuff. And then in the evening, I'm going to play some hacking games. And then on Sunday, I am going to work a little bit on the engine. I probably won't have decided exactly how I want to do the hacking, but there's a lot of cleanup to be done in this engine, like renaming AI to Brain. There's one part in particular that I really hate the way that I structured it, and I really want to redo it, which is the way that the NPCs decide what action they're going to take and then take that action. It's all done separate because it's ECS architecture. So there's different systems at play that handle each part of that, and I hate the way that they communicate with each other. So I would want to come up with a better way of doing that, and also move all of this code over to the engine, which also means open sourcing it. Also at some point look into it's not called STD, SDL. Yeah, SDL or Raylib or some other library that I can use as a backend to make my game engine cross-platform without having to, write native code for 3 different platforms on top of my own. I want to make it have... I really don't like the way that I did the art. The flat 2D pixel art type of aesthetic is really not my thing. So I was considering a Sims 1 type of aesthetic. Really, I would like to do 3D, but that's a gigantic can of worms that I'm not super interested in opening right away. So 2.5D kind of aesthetic like this. Actually, the game that made it click was Project Zomboid, which I might play a little bit in the evening after the hacking games, just because I love that game. I love the way that it looks. It's if I have to do a 2D or 2.5D type of game, I would want it to look like this, or like the Sims one, which is what it inspired by. So yeah, while I decide how I want to do this hacking game, I want to make those improvements to the engine, and I am going to be doing it on... Oh, I want 3 days free of the best software for gamers? Oh my god, I only have 3 minutes. Alright, you guys, drop everything. We have to do this right now. No thanks, I don't like free stuff. Yeah, because when it's free, you're the product. Yeah, so moving most of this code over to the engine, improving it, and making, again, probably not making a game with it right away, but just starting to build an engine. Exit lag? What? Oh, the website. I see. Yeah, I just came here for a screenshot and I can't even like find it. Where's the screen? Oh, is it this one? What the hell is going on here? I'm not working on my game engine. I'm saying that I'm gonna work on my game engine on Sunday. So I might dedicate Sundays to that, which is also like a little change in pacing and content and a little unwinding from operating system development for the weekend. Okay, this is kind of what the game looks like. Can I please get... Okay, this is their website. This is their official website. So I'm hoping to find some actual screenshots of what the game looks like on their website. Bro, they don't want us to know what this game looks like. All right, well, I feel like we've seen enough for you to understand that I'm talking about a 2.5D type of aesthetic. So yeah, those are the improvements that I'm going to be making. Tomorrow night, probably going to be playing some games, probably including this one. Ew, why did this newspaper talk about it? Fuck these guys. Stream cutting out pretty badly? Oh, that one's on you. That doesn't look like it's on me. I think, I'm not sure. Yeah, okay, so playing some hacking games, some games with that aesthetic tomorrow, and then working on the game engine Sunday. Tomorrow afternoon and today and Monday, I'm gonna keep doing operating system development because that is still my main focus. The engine is secondary, which is why I'm working on it 1 day a week. Yeah, on stream. Off stream, I can work on it whenever I feel like it. And hopefully by the time that I decide what type of game I want to make, how I want to do this hacking stuff, well, I'll have a better game engine to build it on. And one thing I have to say I really love about custom game engines, as opposed to making your... Oh, they really added AI mode to the search bar in Chrome. Jesus Christ. As opposed to using Unity or Unreal or one of those, Godot even, is that you can prototype whatever you want so quickly when it's your own engine. The problem is that you need something super simple like collisions. You have to build the whole thing from scratch. So prototype, yeah. Features, it's gonna take a while. Once you get to the point where it's like pretty good, You can do features pretty fast too. And honestly, making your own game engine is... I suggest it. I suggest it. But yeah, that's for Sunday. That's not for today. Okay. Today, okay, so virtual addressing seems to be working well, and I was thinking, yeah, of standardizing somewhat the way that processes work. Not entirely sure where I'm going with this one, to be completely honest with you. But this is the way that my system is laid out right now. We have over here the process memory, which is divided into like your there is a way to type directly into these boxes that I cannot find. Is that it? Did I do it? Yeah, I don't know how I did that. In other times it hasn't worked. Okay, so the way that processes virtual memory is laid out is you have the code, you then have read-only data, you then have read-write data, and you have uninitialized data, which is usually read-write data, but it doesn't have a default value to it. Not zero, not nothing, empty, uninitialized. And then, like, that's what comes into an alpha file. But then you also have a stack and a heap, which can grow dynamically. So this is the way that my processes are laid out. This is one translation table into the system, handles all of these addresses. Then there's another one, which is in high mapping, where you just have the kernel. And internally, the kernel is laid out in the exact same way. It has code, read-only, read-write, uninitialized, stack, and heap. Same thing. It actually has multiple stacks and heaps for all of its processes, because it does have multiple processes. But for the sake of simplicity, kernel. Right? So you access a process's data like at address 0x1000, and it goes here. And you access something with FFFF at the very beginning of it, the first 16 bytes of it, bits of it, the first 2 bytes of it being set to 1, to the maximum value, it goes to this table over here, and so it goes to the kernel. And that way I can have multiple processes, all of which share the same addresses. Hey, Stony. And then the kernel is at this address, for example. Okay, so this is the way that the system is laid out. When I do context switching, so when I switch between processes, I stop looking at this table, I move it out of the way, and I move this one in. And now this becomes what's currently active in my system. So you try to go to this address, you end up in the code for this process. And this one is unaccessible, which is cool. But what else can I do? This is what I meant by standardizing things a little bit. Essentially just predetermined places in memory where I would want certain things to sit. Not hard-coded, always the same, just predetermined so that the structure of the program is kind of known ahead of time. Kind of. because the way that it's currently laid out, it actually looks a little bit more like this, right? You have the stack and the heap, and actually you could have like, the heap can look like this because it can expand. It expands anywhere in memory. So it can look like this. When you started running your process, you had your stack and you had your heap. But then the heap grew, and it just so happens that it grew here because there was empty space here, so it used it. And then it grew again, but there wasn't enough space here, so it grew here. So it's all over the place. And also, the stack is sandwiched between two pieces of the heap. Which means that it's technically possible to override the stack with the heap or the heap with the stack. And also the addresses for these things is something like, not sure about the number of zeros there, but looks a little bit something like this because it is a physical address. This is the same address in physical and virtual memory. So if I put the physical addresses here, it comes in a little bit easier to understand. So the code actually sits at this address, but then it's mapped to this address. So you access it through this address. The heap is mapped to the same address that it's actually at. And again, it's quite fragmented. Like this. First you access the one that's at 6, then the one at 4, then the one at 7. So ideally, the way that I want to structure my processes is that, okay, we have the code, read-only data, read-write data, and uninitialized data as they are set up by the system itself, by the ELF file itself, I mean. I'm not going to touch those right now because that would mean messing with the file format. And to be honest, I'm not entirely sure how people are doing custom executables. I don't know if they're doing like custom compilers or modifying the toolchain compiler. I'm not sure how other operating system developers do it. I do wonder if the OSDev wiki can be of any help. I've been able to access it quite often recently. Well, most of the times it's actually down. Oh no, executable and linkable format stands for ELF. So that's not what I was going for. I wanted executable format. I have a custom toolchain ported a C compiler, but the assembler and linker are fully custom made. For formats, I use ELF and Dwarf. Makes sense. Okay, that's what I was wondering. Like, if I don't want to use, I mostly don't want to use Dwarf anymore. I hate that. I hate that format. But like, if I wanted to move the ELF format to enforce certain rules that I could define in order to structure my program in a standard way, would I have to modify the linker? Is the question. Would I have to make my own linker? And it seems like the answer is yes, but it's not something I want to mess with right now. I would go the weird way of compiling ELF, PE, and then converting the binary to my own. That's another option as well. I'm just wondering how people do it. Because I have seen, especially on the subreddit for OSDev, a lot of people explaining their custom formats. And Infinite Coder, who is here sometimes, has also shown me his format, but he's working on a compiler, so that kind of not the same thing. Holy shit, we're pulling out the needn't. Although, this would have been really useful for me to read because I actually ran into this issue in Doom, where the BSS was not being loaded because it's not actually in the executable file. So it was going out of bounds because I didn't know that I should have allocated some space for this, which I can now do, and I don't think I'm currently doing. I need to check. No, I think I am. Yeah, I am. Yeah, totally. When I use ELF to link my stuff together, but to generate the OS image, I convert the ELF to a custom thing that is ready to load. But in my case, it's not the typical thing. For an architecture, I also designed, so I control every part of the process. I'm this close to the same thing, so yeah. I do want to make a compiler at some point. And actually what I want to do is I want to replace the multiple steps in the compilation process one by one. And use my custom tools to my advantage. But currently I'm not doing any of that. And okay, we confirmed what I thought, which is that if I want to mess with the structure of this, I have to mess with, I have to either enforce some rules that you have to follow when you're compiling your program, which I would rather not do. I want to make it so that you can just compile your program as easily as possible. I don't want to make it harder for people to make programs, mainly myself. But yeah, I don't want to do that. But eventually we'll get to that point. You'll have to use my own compiler. But until that's a thing, well, this is what we got. Maybe I might be able to do that as a first step, is convert an ELF to my own. Hey, D-Fury. At some point, I would like to have C++ support. Yeah, I would need to have C++ support, actually. Come to think of it, if I make my own compiler, I can't just make it for C. It has to be C and C++. Well, not necessarily. Well, yeah, necessarily. All right, we're not making a compiler today. Let's not get ahead of ourselves with the horrors that I will have to experience probably next year. Let's leave the compiler for 2026. That feels like a 2026 adventure. All right. I don't have any hair ties or even my sunglasses to keep my hair back, so I'm just gonna put these on, even though they're connected to my other computer, so I cannot hear anything. Oh well. All right. Again, so over this part of the code, I won't have any control. Over this part, I have control, and I can avoid fragmentation of the heap. And another thing that I'm quite interested in doing is separating the heap from the stack with unmapped memory, so that if you go out of bounds in either of them, it faults the program. Rust anyone? Rust anyone? No. Rust no one, thank you. Okay. So that's the plan. Instead of having the heap start here, then grow over here, then grow over here, then continue growing over here, all fragmented and out of sync, we're going to want to map it and the stack better, which I don't believe is going to be too difficult. And if you're seeing this part, then I am editing the current live stream into a short where I said, this is not going to be too difficult, and then cut to a part where I'm literally crying over how difficult it is. So if you're seeing this, it was that difficult. If you're seeing this on short, if you're seeing it live, I'm just talking. Okay. Please don't be that difficult. For the love of God. Okay, my own C++ compiler. I don't know about that. Okay, so yeah. What I'm doing with C++ is pretty standard. I'm not going crazy with it. The craziest thing I have syntax-wise is lambdas. Maybe I just want to make a C++ to C compiler. Maybe I just want to do that. That might actually be a good starting point for my compiler toolchain. All right, let's not bother with that right now. That and the conversion from an elf dwarf to a hobbit form. Actually, Hobbit, I'm pretty sure is copyrighted, which is why D&D uses halflings. So I'll just have to call it halfling to avoid Tolkien rising from his grave to sue me. All right. So right now, heap, stack, heap, and heap are all mapped to identity mapped to the same address that they're actually physically allocated in. Sucks. So instead, we are going to want to allocate them at okay, we actually know the last address that was given to the program itself, which we're not going to touch this part, but let's say that the program ends at this address. Or after alignment, because we want to align stuff to a page boundary, it ends at this address. In that case, we'll want to put the heap, wait, not at that address, but one page forward. If I put it one page forward, then what I'm doing is I'm leaving a page in between. So it will look like this. This unmapped space means that if you go beyond the stack, like here, it will fault, because if you access any addresses here, it will fault because there's nothing supposed to be there. Klime, a graphic lifetime. So with different sessions in memory. Hey, what? Kernel lifetime. Hold on. I think I know what you're talking about, but I'm not sure. No, this is not. Do you mean like loading and unloading pages of memory into the disk for like swapping? Is that what you're talking about? Because I've never heard of graphic lifetime or kernel lifetime. Yeah, I'm not. I mean, the fact that I don't know what you're talking about probably tells you that I don't have that. But I have no idea what you mean by that. Okay. So yeah, the plan is leave one page unmapped in between where the code ends and where the stack begins. Ideally, I could also do the same thing in between all of these, like between the code and the read-only data, between the read-write data and the uninitialized data. Not necessarily. For that matter, these two are essentially the same once you have initialized them. They're the same, so. Maybe not. And like I said, I'm not touching any of this, so I don't care about any of this. But for the stack, we're leaving one page before, one page after. That way, you go past the stack, you fault. And for the heap, we're also going to be doing the same thing. We're moving the heap one page away from the stack. That way, same thing happens. You go past the heap trying to go into the stack, you fault. Obviously, you go far enough, you'll still access the stack. Because, like, that's a valid address. I cannot stop you from doing that, but you really have to fuck up really badly for that to happen. Okay, so this one will be mapped to 1, 3. 1, 2 is skipped. And then these two are mapped red. These, we're gonna make them green. This, we're gonna make green. This, we're gonna make green. Just to make everything pretty. These, we're gonna make blue. This boundary, we're gonna make it red. All right. Okay, so that's what it's gonna look like. It shouldn't be difficult. Cue to me crying again. for the short. Okay. The process loader is actually currently in charge of mapping the virtual addressing. So it's the one that's doing this part. It's assigning this physical address to this virtual address and then everything after that. But everything here is currently identity mapped. So this address gets mapped to the same address. Instead, we'll map it to this one. We actually know what the maximum address is because we need it to calculate the size of this in order to do the mapping. So it's pretty easy to just know where this boundary is, which is where we'll begin working. Except we'll want to keep track of it after we're done allocating the process, because there's heap allocations, and heap allocations need, you know, when you start a process, it actually looks like this with heap 1. And then when the first heap is not enough, then you map over here. You create more mappings. So you need to keep track of where was the last place that you mapped. Okay. In order to keep track of that, we are going to add a new field to the process, which already has 1,000,000. How many is that? No, the line 65. Okay, minus this, that would be like 27. Minus this also 26. Okay, well now it has 27. We are going to keep track of the last VA mapping. And last VA mapping starts at this maximum address, which is going to actually be aligned on a... Just going to copy this code off of here real quick. No, not there. Okay, after I'm done mapping these sections and I start doing the stack and stuff, here, I'm going to align this maximum address to a page boundary. And then I am going to assign it to the process's last VA mapping, which right now is pointing us here. We'll immediately move it actually to point us, well, I put it on the wrong side. Okay, so it's pointing us here or here. Now we want it to point us here. So we map the stack here. And the stack is currently 1 page. I should probably make it bigger, but whatever. Oh, we're actually fixing this to do. Okay. Last VA mapping is going to be increased by the page size. That way we're leaving space for that. At which point we will need to map the stack. I'm going to put it in a for loop, even though right now that for loop is useless because it just runs once. But eventually the for loop, if I grow the stack, that for loop will be bigger. So absolutely I'll need to map it multiple times. Oh, I'm already doing that for loop actually. No, physical address is I. Virtual address is that's not the best way to do it. Yeah, okay. It's I minus stack. Proc VA last mapping plus that. Okay. And it is... Why is it mapped to read only? It shouldn't be mapped to read only. This is kernel. This is stack. Stack is read write. Well, luckily that wasn't working. I completely ignored that there's an ad on Twitch. Damn. Cool. Actually, I'm going to put it there. And then I'm going to do proc last VA mapping plus page size. There we go. That way it updates. And I'm gonna at least wait for the last 20 seconds of the ad to be over. All right. Well, 10 more seconds. But the stack should indeed be mapped to Alright, we're back on Twitch. Didn't realize there was an ad. So I mapped the stack in the meantime. I think. Let's see if it worked. Before I map the heap, let me check if the stack works. Pretty much all programs use the stack, so should be pretty easy to tell if it works or not. Seems to work. And the log here should tell us that the stack is located at 13. Oh, wait, is that the exact same address I told it? No, it isn't. I used 11. It's 13. But super close to the address that I said. Although, to be fair, I was basing those numbers off of what I remembered. Alright, let me try as well the cat dev console. There we go. Okay, everything works fine. So the heap be mapped to a virtual address seems to work. Okay. Now, this is where it gets a little bit more complicated. Because I can easily do the same thing for the heap, right? Where I simply just instead of using the old address for the heap or the physical address for the heap, I use the virtual address for the heap. Let me see if this crashes, just making sure that everything's as expected. This should crash. It does crash. Good. Okay, that should have crashed because, yeah, we're putting the heap in a virtual address, but we haven't mapped it. And again, the heap is mapped as read-only, which is not working. Wait, okay, I also mapped it here as executable, which it shouldn't be. All right. With the virtual address for the heap being this one, then we'll want to increase the page size again to indicate, hey, we've already mapped the heap there. And then that's it. Am I doing this part twice? I feel like I'm doing this part twice. No, I'm not. Okay. All right, so that should map the heap to a virtual address. Yes, it seems to be back to working. Jesus Christ, it's cold as hell. My hands are freezing. Well, only one hand, I don't know why. Okay, here's the problem with the heap though. If I don't identity map it, it probably will work at first. Yeah, but if I try it with the terminal, for example, which the cat process uses a lot of memory here, it will fail. Whereas if I map it to a physical, nope, it also fails. Yeah, come to think of it. Wait, why does it fail? Why is it failing? Come to think of it, it shouldn't be failing. Now it's failing here. P-alloc is page alloc. I mean, at this point, it was all working. No, it wasn't. I'm just wondering what changed. Okay, it's that. Okay, got it. Okay, so I'm not ready to move the heap over to virtual address yet. Because, like I said, the heap grows. And for example, when I'm trying to read that file, it uses 3 pages, which means that the heap is definitely growing. Actually, all 3 of those pages are outside of the heap, so all of them involve mappings, all of which happen in well, actually in the same place here. In the malloc function, malloc syscall specifically. We have to check if the address is bigger than the context last VA mapping. Well, no. I need to check if we've allocated a new page. This is not how you check that. This is not how you check that. Okay. This is kalloc, which internally has a few cases in which it allocates pages of memory. This is one. And this is another. Thinking of building an emulator similar to our operating system? I don't know, but I'm assuming yes, kind of like a hypervisor. Yeah, it should be. Okay, so I need to know when this is happening, when this is happening, and when this is happening. Yeah, to be fair, yeah, I guess it depends on how you want to implement the emulator. Wait. Simplifying this code a little bit while I'm at it. Okay. Okay, so I feel like these should be mapped to high VA. But this is the one I care about. This allocation, I need to also map it. And then this allocation, I need to also map. There is a kind of naive way of me doing that. Which is that if the address is bigger than the processor or context's last VA mapping, then you need to align it, or actually not the address, but the page address. Using the alignment code. That's actually super simple code, but I keep just copying it. This one. Except, no, not quite. It's actually super simple. It's just the address and the not page size. No, yeah, not page size -1. That was correct. And if the page address has changed, then we need to do a new mapping. Which we do in the same way that I've done it here. With this. But no, not int. This one does need to be aligned on a page boundary, so I need to copy this code Okay. Aligning the size like that, plus size. I plus equals granule 4 kilobytes. Then every time that that happens, we need to do with the contexts ttbr the last mapping. The physical address is the one at I. Mir idx normal. What do you mean you don't know that one? How do you know this but not this? They're in the same header. Oh no, they're not. Okay, so if the address returned is in an unmapped page, then we need to map it because we were giving a new page. I feel like, I don't know, alarm bells are going off when it comes to the security of this. But then again, if my kalloc function from the kernel is giving you a false address somehow, mapping it is the least of your problems. Well, it's the least of my problems. You're probably super happy that you found an exploit. Now it works. Wait, does it work? No, it does not. No, it does not. Okay. Let me see what's up. I thought I also made it so that this wouldn't happen, but it keeps happening. Okay, the stack was placed at 2.9. So between 2.9 and 30. No, not quite. Hold on. Why are you at 2A? Oh, because A is after 9. Holy shit. I forgot these are hexadecimal numbers. 9 goes, I mean, A goes after 9. Yeah, that's correct. So they used to be at the same address. Now this one is one forward because that way it, it skips one page. So that is correct. But then there's a translation fault and it's not giving me any information about what's actually faulting. Which is weird. Because that is coming from the core dump. If you have a core dump, you should have had this or this. Except no. Alright. Just delete that if real quick. Hey, goldfish. Alright, that's a little bit more helpful, even if it's a lot of information being shown. Let's get rid of that. And the address that is faulting is, well, that's unexpected. It is 10 bytes into the heap, which should have been mapped. Because I'm saying the heap is located here. Map the heap. Map the heap. Oh, but it's not being mapped for the kernel. Yeah, it's not being mapped for the kernel. Right. Okay. So we actually need to do the virtual address mapping for the kernel as well. No way, why the fuck would I need to do that? That makes no sense. First off, is that the fix? If it is, there's something else wrong. But does it fix anything? Because if not, I'm kind of wasting my time here. It's not. Okay, thank God. Well, yeah, it's not. It's not. Okay, thank God. That did seem a little weird. Okay. So something else is failing. Probably even in this process. If I don't have to type every single time, that would be great. Now this one works. Why the fuck does this one work, bro? That makes no sense. Oh, section already mapped. Am I by any chance remapping it? New page, section already mapped. Yeah, that's wrong. That is wrong. All right. The heap starts at 1400. 14,000. I forgot that this returns a physical address, not a virtual address. That makes things a lot more complicated. Fuck. That makes things a lot more complicated, actually. But that should be easy to do. We're not going to talk about that. Hey, I very much made it clear that it most likely was not going to be easy to do. Okay, first things first. I'm the realist. It's been like a million years since that song came out, and I still cannot stop myself from saying that every time I say first things first. Okay, I want to see what the page pointer is. Because I'm pretty sure that's going to be a virtual address. It is a virtual address. And yet, every time I do an allocation inside the virtual address, it returns a new page. Interesting. I also kind of want to change the way that allocations happen. So that you can malloc inside a page without needing to go through a syscall every single time. Just allocate every time you need a new page, not every time you need something inside a page, but we'll get to that eventually. Right now is really not the time for that. See how this very simple logic of if the page is bigger relies on using virtual addresses in both cases, but this one is a physical address. I completely forgot about that part. I mean, I have a way to fix it. I just don't want to fix it that way. Because the way to fix it is to keep track of exactly all the mappings for the heap. Because again, remember that this one could be here. Well, it could be done like this. In which case their virtual addresses would actually be swapped. So that this one comes before this one. Even though in physical addresses, they don't. So should be easy to do. Should be easy to do. Alok, I have a question for you. How did you so seamlessly translate into a physical address? Hey, Best Creeper. Fuck, this is not easy to do. It is not. Okay. There is option 2, which is that Alok needs to be replaced. Well, not really replaced. I can expand the Alok inner Not sure about this to do. I might keep it, might get rid of it. With a function pointer to a custom callback in case you need to do a new mapping, which will get triggered here and here when you do a new page. That's the easiest way to do it properly. But that still leaves me with an issue. Alloc returns a physical address. I'm expecting a virtual address. I'm just really trying to do it without mappings. Oh boy. Okay, it shouldn't be too difficult actually. Hold on. Page. Info. Yes. Okay. It can be done. Okay. So this Alloc needs to be expanded with a page virtual address, a next virtual address, and a function that is what did I do? Shit. VA map. It is going to be a void pointer function, and it takes in hell no, not even. Because what's that function gonna do? Just map using this and this. Yeah, so that. Okay. Okay, when I make a new allocation both here and here, I'm going to check if page VA and next VA and TTRB, and if so, I am going to do an MMU for KB mapping to the TTRB with the next VA value using the physical address pointer with the attribute index info attributes and the memory. No, it's a little bit different than that. Okay, I'll have to look into how the attributes are done. What I'm not sure about is this attributes stuff. Oh, I'm just doing this. I could just copy this whole block, actually. No, I can't. Hey, Ice Storm. Whose name changed again thanks to YouTube. Okay, that should be it. And then that. I hope. That. And the pointer, what's your problem? You want a uint pointer here. Okay. YouTube moment. Yeah, it'd been a while since they broke anything, so they had to. Except this is info next. And then the value of next VA is going to be increased by the page size, which is a thing that I forgot to do. Okay. So in the normal kalloc, these three all get 0. They're optional arguments. Obviously, we're going to do optional arguments and freaking see like it's nothing. Like it's super common to do this type of stuff. And then we're going to replace the call for kalloc with the kalloc inner, which is going to use, okay, first off, the virtual address for the current page, which is just a page pointer, actually. The next VA, which is the address of the context's last VA mapping, which is going to get updated real time. And then the TTRB, we're going to take it from the context. What is your damn problem? You want a pointer. Okay. And then inside of the allocator, actually, we're calling kalloc at some point in here, which is not right. You need to be calling inner with page VA plus page size. Need to increase it. Next VA stays the same, and TTRB stays the same. Okay, that's the only place where we're calling kalloc inside of kalloc. It's the only case in which it's recursive. Okay, so full logic. This is no longer needed. I feel like I haven't finished doing everything. I need to also translate the address that I return into a virtual address. I think. I'll do that later. Not that any of this is going to work without that, so I'm not sure why I'm wasting my time. Yeah. Okay. Obviously, it's not going to work because... New address? Oh, page 0. I never filled out. I never filled out the actual field that I was supposed to. All right, so let me check real quick. So the first page of allocations should be working now, but the second page of allocations is going to struggle a little bit. And all the allocations are happening in physical memory, not virtual. So I gotta make that conversion, which is done here, here, and here. That part really sucks. All right, no, hold on. This is super wrong. Shut up, Jester. Okay. Okay, I did say I was gonna end up crying by the end of this, so let's go. I should have committed after I got the stack working, because now the best choice I have is to commit myself to a mental institution. All right. So by definition, when I'm in this line of code, I'm allocating multiple pages. So for the love of God, when I'm doing that, I need to run this code every single time using I as the physical address and next VA as the virtual address, so I can map all of them. Except you need to be a pointer. What? Incompatible pointer to integer conversion initializing uint pointer. Oh, okay. Okay, so now I'm mapping all of those pages. And every single time I'm updating the next VA. After I use it, which is correct. Whereas here, I only have one mapping. And in that mapping, I am like, okay, I'm creating a new page, so I need to map that one to the next VA. That is correct. That is correct. The problem is simply that in here, I need to return the first address. Like that. The first address. Here, what I need to do is I need to return the void cast of the page VA and the results address inside of the page. Probably gonna have to do this a bunch of times more. No, just one. Okay. So that should return virtual addresses every time. I'm done. I'm done. I'm done. I'm officially a Minecraft YouTuber now. Now, okay, let's go. Genuinely, where did it crash? Oh, fuck. I changed the code in a way that it shouldn't affect the old addressing. Like, what? The old one should have stayed exactly the same. What happened? Page VA is explicitly 0 everywhere. Unless you're calling kalloc inner. Which we are. Because... Okay. Okay, I understand. Okay, I just need to understand how this mapping is happening. God, I'm so confused. Virtual addressing is fun, obviously. You can just tell how easy it is to do. Something here is clearly going wrong. All right, there we have it. Page VA is somehow 1,000. Bro, how is it 1,000? It should be the same as the page pointer. How did it get to be 1,000? Cakewalk. Indeed. All right. Very surprising. Oh. Okay, it's because page VA is being increased by the page size. But like, only if there is a page VA. Otherwise, it needs to be 0. Dog process doesn't work. Great, I broke it more. Holy shit, what is this address? What the hell is that? What the fuck did I do? Okay, so I'm mapping 14,000, which is the current location of the heap. I feel like I'm doing something wrong here as well. Yeah, okay. Kind of skipping this part. After I map the first page of the heap, I need to go to the next pointer. Because this is a next pointer. It's not a pointer to the last. It's a pointer to the next. What the fuck happened now? I feel like that's a bug that's been there for like a month or more. I just haven't found it. Okay, dog process works again. Cat dev console does not work still. System UA. Okay. According to this, the heap is located at F000. Okay. But the page pointer, 10,000, is wrong. No, the page VA, I mean, is wrong. Because you're not pointing to that. Entirely wrong. Okay. So we're starting with an address of F000. And yet the allocation that it's trying to do, it is unable to do, because then it moves the page VA to 10,000, which is one page forward. So clearly it was unable I hate when it's this process that crashes because I have to type that in every single time. Yeah, it decided that it needed a new page. So it gave it a new page pointer. And it is returning the wrong result. You're supposed to be returning 10,030 instead of 390. Okay. Tell me which one is failing first off, because I have two logs that are exactly the same. And this is not super helpful. Come on, I can do this without crying. In case you were wondering, why do you want to do some game development on Sunday? Oh, so I don't have to do this every single time. New page. Okay, second. The second one is the one that's failing. Oh, wait, never mind. Hold on. This is the result. It's not wrong. I'm just not reading the address being returned. VS Code is pretty good. I don't see the problem with it. Yeah, okay, I see some problems with it. I'm not switching to Vim. It's 2025, for the love of God. Okay. Why not Google's editor anti-gravity? It's also anti-logic, mostly that. Okay, no, so the addresses for this page, VA 10,000 is working correctly. IntelliJ fan. You know, I've heard. Isn't it paid? Don't you have to pay? I feel like you have to pay. I don't know why. Maybe. Maybe not. Maybe I'm making that up. Wait. Hold your horses. Vim still claps. Yeah, but it's 2025. I want to use a fucking UI mouse-based application, for the love of God. It would have been useful for me to log how much memory I'm trying to allocate, because clearly this is not working. But okay, the virtual addressing is working. It's paid and God doesn't love me. Okay, so that is working. New address with a page. Then I'm doing another allocation. Editor doesn't matter if you don't know what you're doing. Also, just use whatever editor works for you. Learning a new tool is just taking time away from what you're doing, to be honest. So why do I use VS Code? Because it's simple. It doesn't get in my way of programming. If I see one more hour-long episode of a podcast or a tutorial on how to customize Vim, I'm gonna lose it. Because during that hour, you know what I can do? Code. VS Copium is pretty good, I'm not gonna lie to you. Nobody cares about Cursor until production breaks. Cloudflare, Amazon, Azure. Except even then, nobody cares. So, what the fuck do I know? Shit, okay, I gotta take out the trash, and there's an ad coming up. So I'll be back in 3 minutes. And then I'll figure out what's going on here. All right, we're back right on time, and I got a hair tie. Though I don't think like I did a particularly good job with it. Just like a little bit of hair sticking out here. Let me fix that. Saw some ex-Unity dev cry about why everyone uses VS Code over Vim or some shitty subscription-based editor. Jesus. Right, OBS, you're not helping. Why is there a random red line on top of my webcam? I'm using it as a mirror. Okay. Why am I not surprised that people complain about other people's editor choices? Again, the time that you waste talking about other people's editor or code, like programming language choices, you could spend that time coding. In the same manner that people who started coding with Vim probably don't care about using new editors because they're so used to Vim. That way, like, any new editor will get in the way of them coding, and Vim doesn't. For me, it's the opposite. It's also why I don't like a few content creators here and there that, like, I feel like they base most of their content around, not around code, but around the act of programming. Like min-maxing programming in a way. Trying to like get the absolutely best editor that's the fastest with the fastest configuration, and like, I'm just writing code, bro. I may be 1% slower than you, but the time that you wasted configuring your code or your editor to be exactly perfect, I just spent it coding. That makes me overall faster. Also, I don't care about speed. Because if it crashes like this, then who gives a shit what editor you use to make it crash like this? You fucked up, and that's all there is to it. Interesting. It's the cat that's crashing. Not. Huh. If it's cat that's crashing, then wait. Okay, I know what it is. I know where the problem lays. Some inter-process communication hack that's no longer valid. No, not here. 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 I still don't know why this is called bin mod. This is such a weird name. Bin module. That's why it's called that. I should probably change it if I don't remember that off the top of my head. That's just not a good name. Yeah. I'm assuming. That's gonna be F9010 or whatever it was. No? Okay. Why are you crying? You weirdo dog. Weird dog, if you want to shorten that word. Also, he's warm. My hands are like freezing, so I don't mind him being here. My black pants do, because he sheds a lot of hair and then it's really hard to get it off your clothes, but I don't wear these pants too often, so it's fine. Alright. You're calling out yours. Okay, it's not what I thought. Surprisingly. Cold hands mean cold heart? I think it just means like, I don't know, anemia or something. Are you hitting the microphone? Bro, come on. Probably anemic or something, I don't know. Is this address literally not going anywhere? Or are we not even getting this far? Is that what's happening? Don't look. Don't look at the cat. He hates cats with a passion. No hands means no heart. Sound logic right there. What's your response to that? Weird dog, and then it crashes. Oh! Well, well, well. You see, fuck's sake. This little hack is trying to allocate the argv and argc for the process inside of its heap. Except its heap is no longer, he's smelling the keyboard right now. It's not exactly coding. He's just getting used to it. He's like, it doesn't smell like you use Vim. What do you use? VS Code. Ew. Oh, Codium? What do you use? You certainly don't use cat. Alright. Bro, seriously. Atravessão. De verdad. Don't. Sorry. Okay. Yeah, so I probably shouldn't have been doing this in the first place. So maybe I should have, this is an opportunity to do things properly. But I'm allocating the arguments of the process into its heap. And doing that is not going to work because guess what? I'm in a different address space right now. And that heap is not valid. If I could get its physical address, amazing, but I can't. So what to do? What do we do, Chester? Actually, how do processes handle this? The Rust programming language for, of course, I feel like, oh, I'm gonna open this one. It has nothing to do with what I'm looking for, but I'm sure they've overcomplicated argc and argv, and I want to know what they've done. But let me first look at the issue. Unix-like systems put them on the stack. That's reasonable. But unfortunately, I am putting them in the heap. And unfortunately, both of those are virtual addresses. So for both of those, I have to figure out what to do. Moving them to the stack is probably going to make it easier. Because then I don't have to do an allocation. The step is very simple. Just... But either way, it's looking like I'm going to need another field in this goddamn thing. That keeps track of where the stack is physically. God damn it. Let's keep getting worse and worse and worse. Are you serious? Okay, then I can... Oh my god, this dog. Bro. Okay. Instead of doing a k-alloc, what I'm going to do is use the processes physical heap, no, physical stack, right? That's the top of it. Yeah. Allocate in there. And then I'm assuming what I have to do is reduce the stack by the total. Reduce, right? Yes. To say, hey, this much memory is taken up. You're gonna fall. No. I mean, yeah. Virtual memory stuff. There's a lot of shit you need to consider, and everything is now 2 addresses instead of 1. I swear to... Oh my god, this dog. You're lucky you're warm. Okay, so the arguments are working. Except... Why is the stack higher than the... That's not right. Your addresses that are not analogous to the physical ones? Yeah. This is clearly breaking at some point. The result is becoming a virtual address. You shouldn't be doing that, brother. Okay, we've moved forward. I feel like I am gonna end up crying by the end of this. Okay, you're ready to go back to the bed, please. Thank you. Use linear algebra with matrices to define 3D vector space in your memory. Huh? Okay. Bro, we were doing so good using virtual addresses, translating so seamlessly from virtual to physical so easily. And then this shit came along. Because when you free memory... No! Okay. What was working is that when you do allocations, it's always done with the physical address. Until it isn't. So here, this one here is the full physical address that the allocator returns. Here it's physical, so it has this 43, 43, and then this is a virtual address. Because once you free memory, you're putting that memory into the pointer where you're freeing it. And that is becoming a virtual address. So this, the free list is becoming a virtual address. But I can do page or block and a PTR, I guess. Or I can transform this into a pointer, block and FFFFFFF. No, that macro is for kernel mappings. This is completely different. Because this is for virtual addresses that aren't identity mappings. Oh, actually, why the hell am I not just doing this here? And leaving this as I... Bye, MX. Thanks for joining. This is now because we're doing virtual mapping to a completely new address. But when we free, we can also do the same conversion. Except how the fuck do you intend to do the same conversion here, bro? I don't really have 2 pointers. I have 1 pointer. And that really sucks. Because what I'm gonna need to do is I'm gonna need a function to convert. Okay, actually, yeah, might as well reason this out a little bit. Okay, so our heap is in physical memory allocated at this address, right? Pretty sure I skipped a digit there, but it doesn't matter. This is XL? Seriously? You can't make it bigger than this? Well, you can zoom in. So we'll do that. All right, this is where the heap starts. And I'm like, okay, allocate 16 bytes. So it goes to this address. No, wait, okay. Then I'm telling it, okay, map this to this address right here. This is the virtual address. I'm going to do virtual addresses in blue, physical addresses in yellow. Or actually, what colors did I use here? Blue for this one. Okay, green. Okay, so blue for the physical address and green for the virtual address. Okay, so this corresponds to this. The program keeps track of this. That's it. That's all it keeps track of. And then it goes like, okay, can you allocate 16 bytes for me? So it's like, okay, I'm going to allocate 16 bytes for you, which is, this is the page that you have. So the address is this one. But actually, internally, what it does is there's a header in here. Both of them have a header. And that header points to the next free block of memory, which is 4390010. I'm not responsible for my family business, sadly. They don't pay me for sponsoring them, so I can't do free PR for them. Okay, so yeah, in the header, it has a pointer to the next free address in memory, and this pointer is physical at the beginning. So I'm like, okay, can you please give me 16 bytes of memory? And it's like, yeah, okay, here you go. Oh, this pointer is physical, so it's blue, right? Here you go. I'm gonna give you the next pointer that I have available. And I'm also going to do the conversion for you into the virtual address. So there you have it. There's your pointer. And then I'm like, okay, I'm using it. Thank you. Okay, I don't need it anymore. So take it back. Oh, and by the way, this got updated to reflect the next free pointer, right? But now I freed this. I'm like, okay, I don't need it anymore. Can you please free it? When I free it, I update this pointer to this value, because this is now the next free pointer in memory. And it's a virtual address. So next time I try to do an allocation, it points to a virtual address, and my logic to do the translation kind of breaks, I think. That's what I'm thinking, because eventually it starts crashing. And what I need to do is when I'm freeing memory, I need to translate it into its physical address. So I am keeping track of the mapped addresses in the MMU tables themselves, which is why I am doing this, correct? What is it? The last 2 bytes is what I need to check in order to know which address I go to. So 37, 41, 45, 46. Yeah. Okay. So I need to be consistent in the allocations that I'm doing. The allocator is using physical addresses. The free function is using virtual addresses. 39, not 37? It used to be 39, and then I realized it was 37, so I'm pretty sure no. $30 and $4 and $8 and $9. Hold on, you're right. It's happening because of what I said. The physical address is eventually being mapped into a virtual address. When it's freed, we're freeing a virtual address, not a physical address. Okay, I swear to God, I wrote 39, and then someone was like, no, it's actually 37. And now I'm wondering what was their logic for 37, because I went along with it, and I don't think I just blindly listened to somebody like, oh, it's 37. Okay, it's 37. But now that I look at it, okay, so this is 12 plus 8 plus 1, 21. Plus 8 plus 1, 30. Plus 8 plus 1, 39. Logically, it should be 39. I don't know why I switched it. But I'm actually not using addresses that high anyway, so it hasn't been a problem. And then 39 plus 9, 48. Okay. Now what I need to do is pretty much the same thing that I'm doing in this function. And then get the entry, the L4 val, and some mask that I don't remember right now. That's what I need. The mask in this case is actually in the MMU copy, this one. Okay. And now, when I free, instead of using the page, I use the phys page, which is going to be an MMU translate of the page as a pointer, which we use here. That way we access the physical memory to be translated, not the virtual one. Well, to be freed, not the virtual one. We always work with the physical memory. Cat dev console. Chill. Jesus Christ. Okay, it is always using physical addresses now. No, we're back to crashing. Ten, 6, 7. T. What? This address is from the terminal, not from the cat process. Sure, 37, not 39. It should be 30. Shut the fuck up. The ARM MMU I overscrolled. Wait, where does it say that? I thought that was just a random. This one? Oh, this one, okay. Yeah, it's just a matter of which index. Oh, this is for ARM v8, okay. Does it say? How many? Here it is. 47 to 39. Where the fuck did I get 37, bro? I feel like multiple people also told me it should be 37, not 39. I started off with 39. Yeah, it should be 39. And don't quote me on this, but I feel like these images might be like from ARM themselves directly. Again, all logic points to 39. Like, makes sense. Just weird. Yeah, I didn't want to open that PDF either. Okay, back to the crash though. The address that's crashing is for the terminal's own contents. Does this have to do with files again? Oh god, if it has to do with files again. Hey, we're making good progress on that. Yeah, because this one works and the other one works. This has to do with files again. Fuck's sake, I hate files. No, why would it have to do with files? The thing I hate the most is that I have to do this and type this in every time. And then I have to scroll through all this. Well, it reminds me a million times that it failed. Assigning process ready. It's actually running the process. I don't have a website now. Okay, well, seems like the crash is happening from here. So I should get some level of GDB being useful. Rare occurrence right there. 387 on syscall.h. C 387. Well, that was absolutely fucking useless. Because I should have set the breakpoint to high address, not low address. God damn it, I hated GDB. I hate it even more now. Okay, hit the breakpoint, backtrace to fucking nowhere. What do you mean address 7? Hello, null deref and Zek. This is giving me like 0 useful information. Holy shit. Absolutely incredible. You didn't also rename Jester, right? No. I feel like the name Jester might stop being a niche reference soon enough, actually. From what I hear. It's a reference, yes. How about you just don't use the terminal? How's this for a compromise, huh? Sounds good to me. You know the funniest thing? This week, off stream, when shit wasn't working, the picture process worked fine. The terminal itself worked fine. Cat didn't work. Because the communication between the two processes is now isolated and messed up. And now it's the exact same thing. Banned from the terminal? Yeah. Non-Linux users complain about the terminal in Linux, so it's fine. I genuinely don't even know why I have a terminal, to be completely honest with you. I feel like I did it out of peer pressure from the stream. Chat bullied me into doing it. I don't even want a terminal. Yeah. So. Bet you feel pretty silly right now. Look what you've done to me. Look what you've done to me. You've made my system crash so many times. It even mocks me when it crashes. Look what you've done, chat. Stare at the consequences of your own actions. Look at that. Incredible work. Alright, guilt tripping aside. This exact same thing was happening this week. I fixed it, and now it's happening again, but for a different reason. Fucking hate the terminal. It's not even the terminal, it's actually like the files and stuff. So even if I just got rid of the terminal, that wouldn't really solve the issue. Alright, no, but the process is running. Because we can see it here, it's allocating. Cat is actually initialized here with a heap at 2A. And cat doesn't seem to do any allocations whatsoever. That's already kind of a weird thing, because it should be making one allocation. here. Nothing is a file in redacted. No, but that's the one thing I like about Unix. That's the one thing I like. I probably need to implement pipes just to simplify the cat process a whole lot too. But damn. Is there any allocation happening? Assigning, process ready. You're doing all these allocations here. These are for the terminal whose heap starts at F. First off, what is the terminal even constantly allocating? It's doing constant allocations here. That makes no sense. Oh. It makes no sense. It doesn't make any sense. But I understand why it's happening. The question is, why is this crashing when this page is mapped? Who is writing to this address? I have someone I suspect. NTFS follows the principle of everything is a file. I heard them referring to Microsoft kernel as like everything is an object, which actually sounds more evolved. It probably isn't because it's Microsoft, but let's face it. There's one thing worse than Unix, it's Microsoft. But okay, here. Other file system, NTFS, okay. I mean, I should hope that in a file system, everything is a file. It kind of sounds, I mean, I would expect it to be the case. Yeah, this is not it. Let's go step by step. First off, why is the kernel allocating a fixed amount every single time? That makes zero sense. So, real quick. If you're gonna be doing this, do it once. Please don't fix the problem though. It didn't move in the slightest, but it stopped allocating so many times, which is great. Now it allocates more than I was expecting to be. Oh no, wait, hold on. Here, here, and here. Okay, that makes sense. 3 allocations. Reasonable. Reasonable. And actually one of them gets freed. Cool. This maybe refuses to do anything with systems programming. I said that on Sunday I'm gonna do game engine development, which is like systems programming again, but just to have something a little bit different occasionally. So instead of operating system programming, I'm doing a different type of system, and we're doing it with Rust. Fuck no, we're not. Fuck no, we're not. I tried to even like prevent myself from saying that sentence. My brain glitched there for a second because I was trying so hard not to say that. Game engine development because it's easier to see what went wrong. Yeah, definitely. Okay. Another thing I want to do. I hate repetitive code like this. Rusty Cloudflare. I am going to do something that's gonna make me delete the VOD of this stream after I do it. I'm going to defend Rust. Yep. I'm privating the stream as we speak. That wasn't because of Rust. It was in spite of Rust. That was a forced on wrapping. Like, memory safety means nothing if you ignore it. So I'll give them that. I'll give Rust that much. Okay, since both GDB and my my thing are failing so much, I need to know where this is crashing. Both are failing so damn hard at telling me where exactly my code is crashing. OpenGL graphic stuff. And you know what the worst part about that is? I don't get to. I won't be able to. I don't get that privilege, essentially. I'm not that lucky. Calling on rev should result in a compiler error in release builds. I blame Rust for that. Well, I think you can enable that. It's up to you at the end of the day. Sometimes you want your code to crash. Sometimes when you know your code crashing means the entire internet crashing, you don't want your code to crash. So it's up on to the use case. There's some cases in which it's like, okay, if this crashes, we have way bigger issues. Like, I don't know. If I do an allocation in my code, like this one, and I don't check if buff is 0, then return false. Because like, if malloc fails to allocate, we have bigger problems, which is ironically what's happening right now. Right, so the problem isn't that the allocation failed, the problem is that translation is failing. So in cases like those, there's some cases in which it's like, okay, if this fails, we have bigger problems. We really don't care about this right now. And like, then you don't want to be so pedantic with unwraps and stuff like that. L32 exec. Where are you seeing that? Probably at this point. Homework on a Friday night? Oh, maybe it's a Friday morning for you and you need to do it before school. I don't know. Execing? Yeah. Except the return from that function is working just fine. Process ready. That's returning. Execute. Then the syscall. Same time zone. All right. Worth doing homework. I doubt this is crashing. It stopped doing the tick, 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 tick. Going to start reading file now. What just happened? My God in heaven. Did it just change because I added a log? That is completely different crash. And yet it happens at going to start reading file now. I don't know why sometimes it makes a click sound. Sometimes it doesn't. But okay, going to start reading file now. That makes sense. I'm assuming then it's happening inside the read. Could also be the put, but I doubt it. Sometimes it crashes at the end of the syscall. Sometimes it crashes in the other place. Oh, good. Great heavens. And like, I think it's cat, though. Because it being inconsistent like this makes me think that we're switching processes in between. Sometimes it has enough time to execute until the going to start reading file now, and sometimes it doesn't. It switches to the new process crashes, and then this happens. So to test it, we're going to simply printf meow and return 0. It's already an add. Damn, that was fast. No. Okay. Meow, process has exited. Oh, but this time the address changed. This time... God, I hate virtual memory. There's an ad starting on Twitch, by the way. Should be starting soon. Free managed page. Holy shit. Here. First off, this is no longer true. Okay. Okay. When a process gets deallocated, we try to free its heap. Except that's mapped to a virtual address, which is no longer valid when we try to reset the process. Yeah, I know there's an ad running. Let me test my theory real quick. This might not fully work. Let me see. Because yeah, I need to keep track of where the physical heap is kept too. Damn. There's a lot of this. Okay, not talking a lot during the ad. Just going to see if this works. I'm using the physical address of the heap now. Why? I just wanted to be done with this. Why did I do this to myself on a fucking Friday night? Oh. Hold on. That certainly worked better. Line 66 of the page allocator. Okay. All right. Okay. Going out or having a gaming session? Hell no. Debugging virtual memory? Fuck yeah. Exactly. Exactly. Tomorrow, there's gonna be a gaming session. We're gonna play hacking games. And then hacking people to pieces games if I actually end up playing Project Zomboid for a bit. Okay. At some point, that next address this one is becoming virtual as well. Who's doing that? When I catch you. When I catch you, motherfucker. That shouldn't be happening. Oh, you. Oh, you. Watch it work. Fuck you. Come on, man. What did I do wrong? Watch it work. Crashes even earlier than before. Fucking amazing work right there. Yeah, because this is entirely wrong, actually. No, it's not. No, it's not. These are full... I should be able to put a print F here without too many issues. Okay, so this is page free list. And then this whole damn thing. All right, tell me what I'm doing wrong. Dead beef, deaf beef is becoming... Fair enough. Dead beef is becoming 41A40 ETH. Which is fair because the entire rolls right off the tongue, right? Damn, I shouldn't have mentioned Project Zomboid now that I'm dealing with dead beef. Let me see the logic of this real quick. The page... The page free list is dead beef? And that means that the page has already been freed, which is not right. Also, I'm seeing here that the address is just being completely messed up. Yeah, no. You don't do this at all. You expect the free list to already be the right value. The only issue, when you're updating the free list, you need to make sure to do it with a physical address. Yeah, block is already first page, exactly. Yeah, I was wrong about that. So the free managed somehow this one that must be getting caused by something else. Only one. That's a good sign. Okay. Page 39F4000 points to this as next. Why the fuck? First off, I just realized those are different nexts that I was looking at. So this is that next. This is the one. I doubt I'm modifying it after the fact. mp-alloc does not return that virtual address, so... Okay. Page AD points to 15F0 as next. That is entirely wrong. That's not even a page. What did I say it was? Points to new page. Is that anywhere? Okay, I'm gonna have to pull the plug on the page pointer. Needs to become a physical address. So MMU translate the page pointer. That needs to be translated. That needs to be put in here. Okay. Keep changing what the crash is, but then okay. Okay, the address that's crashing now is that page 39AB000 points to a virtual address, which is entirely wrong. This is not even aligned on a page boundary, so that cannot possibly be the address of a page. And it's 39AB. I don't see that one happening anywhere. Three nine A. Cat allocated with this, assigning, process ready, end of syscall, exec. 393 gets translated into virtual addresses. Going to start reading file now. It does until it does this, meow, then it exits, and then it tries to clear this page, which points to this, which is so wrong. Because which page is this? That page must be for the heap, right? Let me see. I don't understand where that page is coming from. That's so weird. Okay. I think the process's stack is that address. Why am I even typing information here when literally all the process does is print meow and then crash? But when the process gets allocated, heap at B8000, which then the crashing address is B8000, which points to why is it pointing to this as its next pointer? It's the process's heap. What I don't understand is why it is pointing somewhere that it shouldn't. It's not doing any allocations. So are you making any allocations for it? From when the process is created, what do? You assigned argc. The stack, we're not even using the other thing anymore. What's the address of it? The name of it, mem page. Okay. This just feels like memory corruption more than anything. User process cat allocated with blah, 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 blah. Assigning, and then it fucking crashes. Though it probably crashed in accessing, yeah, the physical heap. The physical heap. Okay, user process, blah, blah, blah. Assigning, next, 650. Am I just an idiot? By any chance? I'm assuming this is overwriting that. Yeah, I was allocating space on the stack to write the arguments, and I was allocating space in the stack to write the arguments, and then I was writing the arguments. I hope that visual representation was enough to show what the fuck I was doing wrong. Swear to God. Swear to God. I'm leaving the meow in there. I was actually going to change the name of the cat process because I was like, yeah, this just reads files. I'm going to change its name, but meow. Fuck's sake. Come on. A null pointer. A null pointer. On the day of our Lord 2025, in the year of our Lord 2025 is what I meant. Not the day of our Lord. You piece of shit. On the year of our Lord. Let me guess. Devon. Meow. With a physical address that's not mapped. Is it now? Is it now? That's number one. That address is not mapped. Number two is this null pointer. I'm not sure where that's coming from. I wouldn't be surprised if it's literally from just this. Yeah, not nargv. It needs to be the original stack. Or actually, the stack. Okay, we've moved forward. I think. God, I hate that it crashes and crashes and crashes constantly. God damn it. Alright, we have an actual address. A virtual address. So now that the cat can just take a dump and tell us where it's crashing. Here. Well, that's not supposed to be happening. Wait, no. Oh, what? This is an old dump that the cat is taking here. Okay, it's this. The argv ist crashing. Oh. Hey, guess what? Same thing. Same thing as before. Same exact issue. All right. Wait. When you press the wrong key, that has a lot less dramatic effect. That probably fixes it. Yeah, one of my hands is just frozen. The other one is totally fine. Nerve damage, anyone? Okay. It's a different crash. Again. No, not kprintf, just printf. . Do you have a path? No. Great heavens. Let me see. Okay. Just fully disappeared, huh? Just trying to read the address of it just failed. And the other one got in the way. 29FFB. Is that wrong? Oh boy. This is weird. Yeah, I need to get rid of this slug because it keeps getting in the way. It's really annoying. Okay, user process allocated with arg at this address. What is wrong with that address? What is wrong with that address? My god. What did I do wrong now? Let me see. I'm allocating a stack for the process. And I'm pointing to the top of it. Then I'm like, hey, I need some of the stack for the arguments, right? So I copy to here till the top of the stack. I put the arguments there. Then I tell you, okay, your stack actually starts here. All of that is happening here. Yeah, so I'm actually starting here, copying here. Then I'm like, okay, your stack actually starts here. And I'm pointing you here to get access to the... So why is it not valid? What is wrong with that? Am I mapping the stack wrong or am I doing this part wrong? I guess the answer lies here. Okay, where you tell me that the process last VA mapping and I. Okay, user process cat allocated with this, where 29000 gets mapped to the physical address 439AA000. And then the arguments are at 29FFA. End of syscall. At which point, yeah, some stuff happens in between. And then I try to open process. I try to open this address. No, not this address. I am trying to access to A000, which is unmapped. Fuck's sake. I literally left a space between the heap and the stack to catch this kind of issue. So why is it happening? Okay, this is a good thing. This is a good thing. He coped. It is a good thing because I specifically created this for this purpose. And excuse me? Okay. Printf LLX. Which is like, this is the string. And this is x1, yes. So it's loading it from the SP16. And then loading that value. Okay. So FFA. Why are you trying to access this address? No way. When it tries to read the path, did it move forward? Yeah. When it tries to read the path, it is not null terminated. Is it now? Fuck's sake, it keeps crashing. Nope, that's not it either. Which also, string length +1. Shit, I'm not sure. Not sure how many characters I should be copying over. Okay, so I'm gonna do cat h. And that tells me it needs to copy over 2 characters, H and the space. That is correct. And yet, it is still trying to put this at FFE. Oh, but there should be an extra space at the end, because otherwise it's going to go to the page boundary. And even that doesn't fucking work. Oh my god. Nothing works. Seven characters. 1, 2, 3, 4, 5. The null terminator. And then I'm leaving an extra space so that the argument gets put at FF9. So it's at 9, A, B, C, D, E, F. It ends at F. So why the F are you then try to access the next page? I'm going crazy. Let me cook. Of course not. Literally nothing I do ever fixes this. Holy shit. I'm so confused. Okay. What is supposed to happen is it doesn't do all these crashes. Mainly. And I'm not sure what's causing them. Okay, it's whatever it's at this address. Which is... This is just a pointer. Isn't it? Arg0 is just a pointer. So like... What the fuck are you going on about? Alright. No. Is it crashing at 208 again? Okay. How can this print possibly be crashing? If the value of argv is 29FFB, then isn't that the address of arg0? Why does that crash? It's 29FFP. Okay. And then the address of arg0, is that not the same? Pointers have a few intricacies here and there that still confuse me. Okay. Yeah. Okay. If I print argv, it tells me argv is at 29FFP. If I then print the address of argv0, the first argument, then it tells me it's at 29FFP. If I then try to assign it to this variable, it tells me that it is at 2A000, which is an invalid address, so it crashes. Now, as to how it's crashing the entire system, go figure. That's probably on me. Round up from what though? Like, that doesn't make any sense. This is just, it's just an assignment too. Like, okay. One of them is going to print the address and the other one is going to print the value of the one cell. And one of them is going to crash. If the address of argv0 is 29FFB, then why, when I go to read that value, it tries to access it at 2A000? Because it thinks it is a UN the fuck doom. What the hell? It thinks it is a 32-bit value, so it goes beyond. I'm assuming. And no, I don't think it's the alignment. I think it's literally the print itself. What if I want to print just how many digits? 4. I'm going to print just 4 digits of the value. So it's going to consider it as a 16-bit int, which is wrong. Wait, no. All right, yes. No. Still no. But if I make the string long enough, even 64 bits, so cat, I make the full path that I'm supposed to be writing even longer than it is. Okay, there it is. It manages to print properly. Yeah, okay. So that's the damn print itself that's failing. How does that make any sense? I swear to God. So if I make the path long enough, it stands to reason that I should be able to print it properly and the crash should be somewhere else, right? Null. So yes, but also no. Though, let's face it, I probably messed up here. Nope, that's not gonna work. Yeah, that should work. Okay. Clearly, all those ones and zeros from before, I messed it up somehow. Okay, arg is empty. Cool. I decided that I was gonna copy 8 characters, which is 1, 2, 3, 4, 5, 6, plus a null terminator, plus an extra space so that it doesn't end on the byte boundary. Then what the fuck happened to that? Oh. Never mind, I'm just printing from the wrong place. And yet, this is printing something ridiculous. What the fuck? How am I so bad at printing, apparently? Let me print the original value, because maybe that's not working right. That's technically a possibility. Yeah. argv, which comes from execute, is not right. Okay. God, this is annoying. argv and argv0 point to the same place, right? If it was multiple arguments, that's a different story, but they both point to the same place. As far as I know. Argument for execute. Here it's fine. Should they? They should point to the same place. I feel like, anyway. Argument for execute? Okay, maybe they shouldn't point to the same place. They're clearly not pointing to the same place. I mean, are you serious? It feels to me like they should be pointing to the same place. And yeah, they're not. argv. Huh. First off, I thought it was an array of null terminated strings. So clearly I'm wrong with that. But even weirder, argv is F700 and argv0 is F6F0, which is 16 characters behind the address of argv. So okay, clearly it is like you're saying. And I've been doing it wrong the whole time. And so long as I wasn't violating boundaries. But how have I been doing it wrong? For the love of God, it's been working. All these copies have been... What? This makes no sense. I just don't understand how this works. So argv comes after argv0. I guess that makes sense. I guess I get it. I guess I get it. But then how the fuck do I copy it? Like... What does the memory inside argv look like? And... Okay. I guess step by step. Give me an address for argv. And then give me an address for argv, object at index I. Did I put those? Yeah, it was supposed to be I and then that. so that I can compare them properly. How is there an ad already? It's been an hour already. All right, F5B0, A0, A4. So dev console and then alignment 16. Yeah. Okay, I just realized I create that string. So I'm responsible for what it looks like. There it is. There it is. I'm creating this array, so I'm responsible for what it looks like. So if it doesn't make any sense, it's my own damn fault. It is also a malloc array. Using this parse arguments function. It is a malloc array of 16 times the size of a pointer. Where okay, I understand. Mm-hmm. You probably cannot hear this because there's ads, but this is the structure. Okay. So I just need to recreate my execute function, my copy function, and make it valid, kind of. Which is if argc is bigger than 0, then we start at argv object at index 0, and we end at argv plus argc times size of uint pointer. The total becomes end minus start. Okay. Yeah, so it turns out ads are done. I make my own argv structure, so I need to copy it according to what I'm doing. It's that simple. And possibly the easiest way to do that, to be honest, is to just no, okay, actually that was solid. This is how many this is all the strings. Right? So all I have to do is copy over the strings, the actual string values. And then what do you mean you didn't expect me to stream? Okay, before I do any string copies, am I doing this right? This is the copy of the strings themselves, not the string copies. I haven't done that part yet. So this is only going to print dev if it works at all. Seems like it didn't. No, wait. Fucking obviously it didn't. I'm not actually doing the copy. There. All right. Okay, so the strings are being copied. Now the argv is not being copied. Because the size of argv is argc times the size of a pointer. And we move back by that much. but we're not actually copying the pointers of them yet. Which and then this. No, okay, this is just a char pointer. This is a char pointer pointer. That's confusing as fuck is what it is. New argv is this value minus the total. And at nargv 0, I am going to put the value of nargvals. And then don't worry about those yet. Don't worry about those. Although we should be worried about those. They will need to be set also, yes. Have I done this completely wrong? I think it's easier if I just do it the same way that the other one is doing it, because otherwise this is just going to be a big mess. It is doing it by mallocing. We're not going to malloc. Oh, It's just this, really. I mean, I need to get it to work with one argument, and then I can bother on making it work with multiple arguments, because I swear to God. This should give me an argument. Cat def console. Even though you crash, it prints out the correct value. Yes. And then tell me what, well, this should have been in here. nargv 0 points to. it points to the correct value. So that is being copied correctly. No. Stack minus total is the same as doing this. Yeah, so by all means. The physical pointer is this one. And then the virtual pointer is being printed by the process itself. Allegedly. Okay. The physical pointer is FF0. Process ready with argv at 29FF8. Oh. I thought that would work. Okay. Let's go back to the visual board here. Right, so we have a certain amount of space, right? And the way that it is laid out is we have one argument, another argument, then a pointer to the first one, and a pointer to the second one. So when we copy it, we take the pointer to the first one, so argv0, and then the pointer to this address, which gives us this area over here. And we copy over that much. There's actually no second argument, so we're not even doing that. So we're like, okay, start at the top of the stack, minus the total, minus this amount. So the top of the stack, which is here, minus this amount, minus the amount of arguments that there's going to be. So the pointers that there's going to be. So minus this as well. So you start here. You copy arg0 over to that by the amount being this amount. So you copy them over with their null terminators and everything. Cool. Which actually prints the first argument correctly. Then it finds a null terminator, so if there's more arguments after that, it doesn't parse them, but they are there. Then, after doing stack physical minus total minus the number of the argument array, it does physical minus the argument array, which puts us here. And so this print is wrong, which is why my prints are different. Two 9FF8. Correct. And then 29FF8, and then this is FF8. So that is correct. There is one more thing I didn't consider. You shouldn't point to this. You should point to, for the love of God, this. The virtual new virtual argument values. Crazy as that is. That didn't work, did it? Not even close to working. Holy shit. Oh, I hate virtual memory so much. Why is the end equal argv and not argv? Because the end of the strings, which come before argv. So the way that the memory is laid out is you get the strings first and then the index to the strings later. Okay, let me start over. Because what the fuck? Okay. We know how much memory to allocate based on this size. But then we don't need to overcomplicate things too much. We can just do a single string pointer starting at 0, which is just going to memcpy a... do we have a string cpy? I feel like... No, I thought that was a thing. All right. Thought it was made in a pull request, but apparently not. argv object at index I. No, that's the destination. This is the there. The size t of the string size is the string length of the argv I with a maximum of 0. That's how much we're going to be copying by into the string pointer. physical string pointer. So nargvals plus string pointer. We will then increase the string pointer by the string size. But before doing that, the new argv I is going to be the virtual address. strn cup. Okay, yeah, but I still need the string size, so this is about the same. Although, that's missing. And we turn that into a pointer. No, you wanted a char pointer. So the opposite. That should give us it will fault when trying to print args, I'm pretty sure. Yeah. This print will fault, which is kind of a good thing. We're back at the very beginning of this. Oh, wait. I'm overwriting shit here that I shouldn't be. Okay. Please work. I'm tired. Holy shit. Okay. Oh, I don't even know. Oh, okay. I put 2 arguments in, which is already not supposed to happen. Holy shit. Holy shit. Holy shit. This is cut off. No crash. The other crash is completely different. And the crash handler crashes because it probably isn't using high mappings. So, yeah, that's why the system crashes over and over and over again. I just realized that too. But, okay. No crash. But no result either. And the shit. So it didn't get copied over properly. Mm-hmm. There's one character missing here. Okay, okay. We're close, we're close, we're close. Come on. Come on, we can get this. All right. This is no longer needed. Oh, fuck off. You annoying little sporadic bug. I don't care about you. Got bigger fish to fry at this point. New string. 10 characters. Dev CCP MSP. So this is correct. And also the number of characters. This is 4. This is 4. This is 1, 9 plus the null terminator 10. Yeah. So, why the fuck is it not null terminated? Can do that to make sure it's null terminated. Okay, I think that worked. Okay, that's enough for today. One of my hands is freezing. The other one is completely fine. Not sure what's going on with my hand there. But let's leave it here for now. I'm tired. 1 bug down, 1 million to go. It's probably like a very tiny thing at this point. I'm coping here. What can I say? All right. I'm going to debug this later on. I see. Yeah. I'm going to debug this later on, tomorrow morning maybe, and we're gonna move on from this shit, hopefully, and virtual addressing is gonna work properly like it's supposed to, and then it's gonna be amazing. And then tomorrow I can work on something new. For the love of God, I need to work on something new. I just don't know what. Something a little lighter. Something not as annoying. All right, well, that's a problem for tomorrow, not for today. All right, so thank you so much, everybody, for watching, for joining, participating, even if it's just to look at Jester. This is going to be fixed by tomorrow, promise. Promise. Stay tuned for that. All right, for the time being, thank you so much. Tomorrow's stream is in the afternoon, so earlier than today. Today was at 7:30 p.m. CET. Tomorrow is going to be at 3 p.m. Yeah, I haven't changed the time of that one, so 3 p.m. It's going to stay like that. I also mentioned gaming for a bit in the evening, but no schedule for that one. And it's somewhat related to game development on Sunday, which is also at 3 p.m. Yeah, so that's 3 p.m. CET, 2 p.m. UTC, which is UK time. And I believe that's it. I'm going to go have dinner before I deal with this shit. And then hopefully I'm going to come back and it's going to be amazing. All right, thank you so much, everybody. See you tomorrow.